Alright, this is lesson 53, solve and graph absolute value equations. Okay, so I wanted to talk to you about absolute value. Just a quick reminder, absolute value is the distance a number is from 0, right? And it always makes numbers positive, right? Does that make sense? So what's the absolute value of negative 2? 2. What's the absolute value of 2? 2, right? It's always positive. Does that make sense?
Yes.
And we use that to understand how far a number is from 0. Okay, so a good way to think about it is like, let's say your house, where you live on your street, is 0 on the number line, right? This is your home. If you go to 2 blocks away at the address of 2, how far are you away from your house? 2 blocks, right? Do you all agree? Okay, let's say I go the opposite direction to the address of negative 2. How far am I away from my house still? 2, right? I'm not negative distance, right? Do you all agree with me?
Yeah.
Okay. So absolute value always makes things positive. So that's kind of what we're looking at, and you'll see how the graph does that. And I'm going to compare it to something we did yesterday. So continuing, this is the form of the absolute value equation. What similarities do you see between this equation and like the line? What's that? Good. Y is equal to mx plus b. This whole portion right here is the same, right? So since they're very similar, they're going to look very similar as well. So, all right. Here are the steps as well. If you're on the video, you should pause it here and write them down before we move on. All right, continuing here. So I'll do numbers 1 and 2. Just watch carefully right now. Okay, before I do number 1, I'm going to pretend that this absolute value sign was not here because I want you to see the difference here. So let's pretend that the absolute value signs were not here, okay? Isn't this a line, right? Isn't that the equation for a line that we did a couple days ago? Would you all agree with me? Yeah. Okay, so if that's the case, I'm just going to pretend like this was an equation from a couple of days ago. This is not how you graph, by the way. I wanted to show you the similarity before we start. So this is our y-intercept is 1, and our slope is 1 over 1, so you're just going up across 1 over 1, and then you're, drawing a line across with your straight edge, all the way across your paper, putting arrows at the ends, right? And then that's your line, right? But we know that absolute value always makes numbers what? Positive, right? Absolute value always makes numbers positive. What does absolute value always make numbers do?
Positive.
Makes them positive, okay? So look at my graph right here. Is it ever in the negative territory on the y right now? Yeah, it is. It's negative right here. Right? Isn't y negative right here? Do we want y to be negative with absolute value? No. So check this out. I'm going to now show you how to graph it, okay? So that was not how you graph it. This is now how we graph it, okay? Okay, so the first thing we want to do when we graph an absolute value sign is make sure that we have it in the right format. We have y is equal to mx plus, or absolute value of mx plus b plus c. So our m here is equal to 1 because there's a coefficient here of 1, and then we have our b is also 1, and our c, there is no c, so we're going to say c is 0, okay, because there is no c. Alright, then we're going to start with our vertex. We plot our vertex by finding it first, so we have to start with our equation, or formula v is equal to negative b over m c. Plugging in our numbers, it's going to be negative 1 over 1, 0, or negative 1, 0. And that is our vertex, okay? Next thing you want to do is make an XY table, okay? If this is our vertex, just like parabolas, this is in the middle, we're going to pick 2 bigger numbers than our x value and 2 smaller numbers. 2 bigger numbers than negative 1 are 0 and 1. 2 smaller numbers are negative 2 and negative 3. Okay? Then I'm going to plug these numbers into my original equation to solve and figure out what the output is of x, or which is y. Okay? So plugging in negative 3. Negative 3 plus 1 is negative 2. Absolute value of negative 2 is 2. Okay? Plugging in negative 2. Negative 2 plus 1 is negative 1. What's the absolute value of negative 1? 1. Good. Continuing, 0. Plugging in 0. 0 plus 1 is?
1.
Absolute value of 1 is?
1.
1. 1 plus 1 is?
2.
Absolute value of 2? 2, okay. Now I'm going to plot my points. And I'm going to graph with a different color so you can see the difference, okay? So, plotting my points, now we have negative 3, 2, negative 2, 1, negative 1, 0, 0, 1, and 1, 2. And I'm going to graph my line. And you're going to notice something here. This is a different color, by the way. I'll turn off the lights so you see. What do you notice about the way the graph looks like? Well, this one's perpendicular, but what else do you notice? Absolute value always makes things what? Positive. So does my linear graph ever go to the negative territory here? No. You see how it bounced back? So that's the concept. Absolute value always makes things positive. This is what the graph looks like, okay? That's the concept. But I want to show you again. How do we graph it, okay? First thing I did is I made sure everything was in slope-intercept form. Or not slope-intercept form. In absolute value form, y is equal to m, absolute value of mx plus b plus c. It was m is 1, b is 1, c there's nothing, so we say it's 0. We put our figure out our vertex, which is negative b over mc. Okay? So it's negative 1 over 1, 0, or negative 1. If this is our vertex, this should be in the middle. Okay? Negative 1, 0. Pick two numbers that are bigger than negative 1, which is 0 and 1. Two smaller numbers are negative 2, negative 3. Then we plug each of these back into our original equation, solve for each, and then you plot the points. Okay? Yes, sir?
With the plus or minus 2 and plus or minus 1.
No, that does not work here. That's parabolas. Is that the same thing as this?
No.
No, that's a different one. Okay? Good question. It's not the same thing. Okay? Now look at number 2. This one's a little bit harder, okay? Number 2. First thing I do is I check to make sure that it is in my correct form. It is. We have our m is 3, b is 2, and our c is negative 1. Start with your vertex first. V is going to be our negative b over m c. Okay? So we have negative b over m, so it's going to be negative 2 over 3. C is negative 1. Okay, so we're dealing with a bit of a harder problem. It's not that much harder, but there's a fraction, so we have to carefully plot this. If this is negative 2/3, we don't want to go from our origin all the way to negative 1. We want to count just to negative 2/3 and then down to negative 1 to here. So you should have a point right here, okay? Then we're going to make our XY table. I'm sorry, XY table. Okay, so if our vertex is at negative 2/3, negative 1, then we have to pick two numbers that are bigger than negative 2/3. What are two numbers that are bigger than negative 2/3? 0 and 1, right? We're just going off on the x-axis here. 0 and 1. Two smaller numbers are negative 1 and negative 2, okay? So plugging these back into our original equation, so looking at negative 2, taking negative 2, plugging it back in here. So carefully now. 3 times negative 2 is negative 6. Negative 6 plus 2 is negative 4, right? Absolute value of negative 4 is 4. 4 times the negative sign is negative 4. Negative 4 minus 1 is negative 5. Okay? This one's a harder one, right? Negative 1. 3 times negative 1 is negative 3. Negative 3 plus 2 is negative 1. Absolute value of negative 1 is 1. 1 times the negative sign is negative 1. Negative 1 minus 1 is negative 2. Okay, next one, 0. 3 times 0 is 0. 0 plus 2 is 2. Absolute value of 2 is 2. 2 times the negative sign is negative 2. Negative 2 minus 1 is negative 3. Okay? Last one, 1. 3 times 1 is 3. 3 plus 2 is 5. Absolute value of 5 is 5. Times the negative sign is negative 5. Negative 5 minus 1 is negative 6. Okay? Then we just plot our points. We got negative 2, negative 5. -1, -2, 0, -3, and 1, -6. Now, doesn't it look like I almost did this wrong, right? Look over here. Aren't my points symmetrical here, right? Does that mean I did it wrong? No. It just means that the graph is shifted a little bit. So all you need to do is just draw your lines. And put arrows at the end because these lines go on forever. That's it. Now, does my graph look symmetrical? Yeah, definitely looks symmetrical, but my points are not symmetrical. So on number 2, even though you might assume that these might copy. Remember that you asked ±1, ±2. On this one they could copy, but on this one, are my numbers the same? Are they symmetrical? No. So you cannot assume that. That's why I wanted to show you this one. This one's probably the hardest type of problem you'll encounter. Okay, in this topic. All right. Any questions on numbers 1 or 2? Okay. So what I'd like you to do. 1 still the 2's. About how we did number 1. Go through the steps, and then 2's take your turn. Talk about number 2. Ready, set, talk. Okay, continuing number 3. Okay. So we got y is equal to the opposite value of x minus 3. So it looks very similar to a line. It's very simple. So is it in the right format? Let's do this one together, and then you're basically copying what I'm doing. I'm going to check on you, so make sure you're participating. Is it in the right format, everyone?
Yes.
Okay, good. So, what's our m? M is?
1.
Good. B?
-3.
Good. C?
0.
0, right? There is no C, so we could assume it's 0. Okay, then we go to our vertex, which is -b over m, C. And you just replace these values with the various variables. Okay, so we got b is -3. So check this out. This is a little bit scary, or a little bit not scary, but you have to be very careful. If our b is -3, you're gonna put -3 over m, which is 1. Okay, and our c is 0. What's -3 really equal to? Positive 3 over 1 is just 3, so your vertex is at 3, 0. So be careful with that negative sign. Sometimes it can double down and you'll have a negative. Okay. Then we do our xy table. If our vertex is always in the middle of our graph, then we know we're going to have to pick 2 smaller numbers and 2 bigger numbers. What are 2 bigger numbers than 3?
4 and 5.
4 and 5. What are 2 smaller numbers?
2 and 1.
2 and 1. Okay, everyone's writing this down, participating with me, right? Okay, then you plug them back in. So let's start with 1. We're plugging 1 back into our original problem at the top. So 1 minus 3 is? Nope. -2. Absolute value of -2 is? 2. Good. Next one, 2. 2 minus 3 is? What? -1. Absolute value of -1 is? 1. Good. Next one, 4. 4 minus 3 is? Absolute value of 1 is? Good. Next one, 5. 5 minus 3 is? 5 minus 3 is? 2. Good. Absolute value of 2 is? 2. Okay. Then you plot your points. Oh, by the way, before we move on, right, are we allowed to assume that these numbers will be always symmetrical or the same? No, right? Because sometimes you have a shifted graph. So always work out all of them. In this case, they are symmetrical, so that's nice. So there's my vertex, plotting my points. Okay, and then you take your straight edge. Of course, you're taking out your ID card or a ruler or something that's a straight edge. Draw arrows at the end of each line. And that's it. Okay, I'm going to come by and check your work. This one I did with you. Okay, we did this one together. The graph. Okay, so number 4. Predict before you even start. Is the graph going to open up or down?
Down.
Down, good. How do we know that? There's a negative on the outside of the absolute value. Even though we want a positive number with absolute value signs, it's still going to be negative. Okay? Is it in the right format?
Yeah.
Yeah. Okay. Even though there's a number missing, what number is missing or what letter?
B.
B. Good. So if B is missing, we know we could assume that B is 0. So we're going to put B equals 0. And then our M is 3. And our C is 2. Okay? Start with the vertex. Vertex is going to be at negative B over M. You could do this along with me. C. Okay. So it's going to be negative 0 over 3. And our C is 2. So our vertex is going to be at 0, 2. Right? All right. What's the next step? Turn to your neighbor. Tell them what the next step is. Okay, what's the next step, everyone? Okay, XY table. Good. So we're making an XY table. So we got 0, 2. What are two numbers that are bigger than 0? Good, 1 and 2. Two numbers that are smaller than 0? Good, okay. These are your inputs, okay? So you're going to finish off the problem now by yourself, okay? Okay, are those the correct points? Yeah. So you got negative, sorry, it's negative 1. We got negative 4 here. Yeah, this is definitely correct. Right, and we could keep doing points forever, right? Because these are two straight lines moving from one vertex, okay? Now, I wanted to bring your attention to this problem. We know it opens down. What else do you notice about this problem that's different than like the last one, number 3, or even number 2? What do you notice about the lines? Are they like the same steepness or the different steepness? Or same steepness or different? Yeah. Does this look more steep or less steep than... It's more steep. Why do you think it's more steep? What letter or number represents steepness? What? B? No.
C.
Definitely not C. Think about lines. What letter? Skylar, what was that? M, right? What's M represent? Slope, right? You see how the slope is bigger here? So it's steeper. Did y'all get that? It's kind of like one of those connecting things, okay? So if you know that your slope or your M is larger, you know you're going to have a steeper line, okay? So that's how that works. The other thing I noticed a couple kids were, they were plotting the points, and then there's a few of you, not just one of you. You plotted your points, and then you had one point like all the way up here, right? Okay, does that look like a good point to you? No, because if you connected it, it would have looked like this, right? It would have looked kind of disastrous, okay? So if you're noticing that your points are not lining up to a V, you're doing something wrong, okay? Even if you have like a sideways V, that would be incorrect, okay? Right now, for our purposes, we are having absolute values graphs that are up and down, okay? Let's do one more. Let's jump to number 6. This one will be like our challenge problem. If you could get through this one, then you will be fine for your homework. Okay, number 6. Okay, so is it in the correct format? Yes or no? Yep. Good. What's our M?
3.
B?
1.
C.
-1.
Good. Okay, so our vertex is going to be negative B over M C. So we got negative 1 over 3. And our C is negative 1. I can't really simplify this anymore, so that is our vertex, okay? Okay, so now we have a bit of a harder problem, right? This is like number 2. You have a fraction, right? So you need to be careful that you're not assuming it's symmetrical. Okay, Okay, so let's put negative 1/3, negative 1. And what are two bigger numbers than negative 1/3? Two bigger integers. Whole numbers. What's a bigger number than negative 1/3? 0, good. What's a bigger number than 0? 1, good. And always think integers. You're not going to deal with fractions the whole time. Okay, what's a smaller number than negative 1/3? What's the next smaller number? Negative 1, good. Next smaller number? Okay, good. All right. So work it out and graph it. On this particular one, you notice that the points are not symmetrical. If I put in 1, 3, 4, minus 1 is 3, negative 1, negative 3, negative 2, 2, minus 1 is 1, negative 2, negative 6, negative 5, 5, negative 4. You see how all these points are, there's no relationship to any of them. There's no, it doesn't look like they'll become symmetrical, but after you plug them in, go negative 1/3 down 1 to here, 0, 0, 1, 3, negative 1, 1, and 1 or negative 2, 4. You know, at this point, it looks a little scary. You're like, did I do this right? Just take your ID card or your straight edge and make sure they're in a straight line. They should be, okay? And you'll notice that even your slopes look the same. Okay? And it's really important that you use graph paper or print the homework out so you got it correctly. Okay? That's it. That concludes this lesson.